Hello friends, I hope you are enjoying my videos. So today we will discuss chemical equilibrium in our today lecture. So we will discuss the complete chapter of chemical equilibrium in which we will discuss reactants and products. Similarly, we will discuss reversible and irreversible reaction, and after this we will discuss about law of mass action, and then we will draw a formula for Kc, that is equilibrium constant, and we will solve some numericals, and after this uh, we will discuss about Kc, the importance of Kc. So let's start our topic. So by definition, chemical equilibrium is a state in a reversible chemical reaction where the rate of the forward reaction equals the rate of a reverse reaction, and the concentration of reactants and products remain constant over time. So it can be represented like this. So if A plus B, these are reactants, when reacts gives C plus D, so C plus D as product. When reactant gives product, so the double arrow means this is a reversible reaction, means that reaction takes place in both the direction, in forward direction and backward direction. So chemical equilibrium is basically a state where the rate of forward reaction equal to rate of reverse reaction. Now let's define reactants. A reactant is a substances that starts a chemical reaction. So reactants are substances which starts chemical reaction. Reactants are the chemical you begin with. So, and they are transformed during the reaction to form products. So reactants are the substances from which you begin with, and reactants are found on the left side of a chemical equation. So this is a chemical equation, and reactants are found on the left side of equation. Similarly, during the reaction, chemical bonds in the reactants are broken and new bonds form to create the products. So when a chemical reaction starts, so the bond between or among the reactants starts to break, and new bonds bonds starts to formation. So in chemical reaction, the bond between reactants are breaking, and the bond of products are start to develop. So example, H2 plus O2 gives H2O. When hydrogen reacts with oxygen, it gives water. In this reaction, hydrogen and oxygen are the reactants. H2O is the product. So these are reactants, and this water is product. Now, what is product? A product is a substance that is formed as a result of a chemical reaction. So during a chemical reaction, the substance which is formed is called product. Products are made when reactants reacts with each other. When reactants react with each other, so product is formed. In key points, products are found on the right side of a chemical equation. So this is a right side of chemical equation, and they are the new substances created after the chemical change. So after chemical change, the new substance is formed, and these new substances are known as product. For example, when carbon reacts with oxygen, it yields into carbon dioxide. In this reaction, carbon and oxygen are the reactants, and carbon dioxide is the product. Now let's define reversible reaction. A reversible reaction is a chemical reaction where the product can react to form the original reactants again. In other words, the reaction can proceed in both forward and backward direction. So general form is when reactants A plus B, both A and B are reactants, reacts, it gives C plus D, and as well as C plus D reacts back and give the reactants. So it means that a reversible reaction is a reaction which takes place in both the direction. In forward direction, that is from reactants to product and from product to reactants. For a reaction, for example, A plus B gives C plus D. Backward reaction, C plus D gives A plus B. So A plus B reactants gives product, and products gives reactants. In key feature, eventually the rate of the forward reaction equals the rate of the reverse reaction. At this point, the concentration of reactants and products remain constant, not necessarily equal. So a phase is established where the rate of forward reaction is equal to the rate of backward reaction, and this state is called equilibrium. So closed system, reversible reaction usually occurs in a closed system where no substances can escape. For example, Haber process. So when nitrogen reacts with the hydrogen, it gives ammonia. N2 plus 3H2 gives 2NH3. It is a reversible reaction. Other example, hydration of ethene. So this is ethene when reacts with water. So anything when reacts with water and the water is added to the product, so this is called hydration. So it gives ethanol. So C2H5OH is ethanol, which is also known as ethyl alcohol. This is another example of reversible reaction. Irreversible reaction. So an irreversible reaction is a chemical reaction that proceeds in only one direction from reactants to product and cannot easily go backward under normal conditions. So under normal condition, an irreversible reaction do not go backward. That is, the reaction goes towards completion. In general form, we can say when A plus B reactants reacts, it gives C plus D. And from products, this reaction do not go backward to give reactant again, but this is in normal condition. Please remember that there are some special cases where you can reverse some irreversible reaction, but this is not included in our topic to discuss. So generally, irreversible reaction are those reactions which are going towards the completion by definition. In key feature, products do not convert back into reactants. The reaction goes to completion. All or most of the reactants are used up. So for example, combustion of methane, when methane reacts with oxygen, so CO2 plus 2H2O and plus some amount of energy are released. So this is methane. When reacts with oxygen, it gives carbon dioxide and water in vapor form plus energy or heat. So this is the example of irreversible reaction. Neutralization reaction is also an example of irreversible reaction. Where the acid reacts with the base, it gives salt and water. For example, HCl is an acid and sodium hydroxide is a base. When reacts, it gives NaCl plus H2O. It is also one-sided reaction, which is also called irreversible reaction. So these reactions go forward and do not easily reverse because the products are stable and removed from the system. For example, gas escapes and precipitate settles down. So after knowing the chemical equilibrium, definition of chemical equilibrium and reversible and irreversible reaction, now let's discuss law of mass action and derivation of expression for equilibrium constant. So by definition, law of mass action states that the rate of a chemical reaction is directly proportional to the product of the concentration of the reactants, each raised to the power of its coefficient in the balance equation. For a general reversible reaction, A plus B gives C plus D, and these are the coefficients. So the rate of reaction is directly proportional to the concentration of the reactants. More concentration, more will be the rate of reaction. So in this equation, A and B are reactants, A and B, capital A and B are reactants, C and D are products, while A, B, C, D are their respective stoichiometric coefficient. You can say number of moles. So forward reaction, by definition, rate of forward reaction we can write as is equal to concentration, the product of concentration of reactant, and the rate of backward reaction we can write as this is forward reaction, F for forward and B for backward. So the concentration, the product of the concentration of products, it chemical equilibrium as we defined that rate of forward reaction is equal to rate of backward reaction. So this is the rate of forward reaction, this equal to this, we can write this equal to this. So look over here, this is rate of forward reaction which is equal to rate of backward reaction. Now send this Kb over here on this side of equation, and we will send this into this side of equation. So Kb will come in divide, and similarly A and B will come in divide. So this Kf over Kb is known as equilibrium constant, which we represent by Kc. So Kc is equal to C into D and A into B. Please note that this large bracket represent the concentration. This is the equilibrium constant expression in term of concentration. So example, for example, reaction between hydrogen and iodine. When hydrogen and iodine reacts, they give hydrogen iodide. So we can write the equilibrium constant for this reaction like this. So we will write over here the product, and this number of mole or coefficient will go to the power. And here the power of hydrogen is 1 and the power of iodine is 1. So I have mentioned over here to understand while we do not write power 1. So Kc is equal to Hi power 2 divided by H2 N2 I2. This is the equilibrium constant representation for the reaction of hydrogen between hydrogen and iodine. Now equilibrium constant and its units. So as we discussed forward reaction rate equal to backward reaction rate. So Kc only works in equilibrium. So Kc, when we write the Kc equilibrium constant, so it only works in equilibrium means that the reaction must be in the state of equilibrium. That is, rate of forward reaction must be equal to the rate of backward reaction. It represents the equilibrium concentration of the reactants and products in mole per dm cube. So this is the unit of concentration. So Kc is independent of reactant and product concentration. Why? Because Kc only works in during equilibrium states. Kc varies with temperature. Kc is a balanced chemical equation coefficient. In a balanced chemical equation, each reactant and products has a concentration equal to its coefficient. Also, Kc represents equilibrium position. If Kc is larger than 1, the reaction is forward. If Kc is less than 1, the reaction is a reverse reaction. Remember that equilibrium constant Kc is a ratio of reactant to product that is utilized to define chemical behavior. As I told, it is the ratio of the ratio of reactant to product that is utilized to define chemical behavior. As I told in the formula, this is the ratio between the product and the reactants. So at equilibrium, rate of forward reaction equal to rate of backward reaction. An equal number of moles of the sides of the equation has no unit in Kc. So if the number of mole of the reactants is equal to number of mole of product, so then there will be no unit of Kc. Look over here, 1 mole carbon dioxide and 1 mole hydrogen. So 2 mole reactants gives 2 mole products, 1 mole of carbon monoxide and 1 mole of water. So 2 mole on reactant side and 2 mole on product side. So the unit of concentration is now the unit of concentration, it will be unitless, no unit. So if the number of mole of reactant is equal to number of mole of product, so then there will be no unit of Kc. Look over here, if we put this over here, so these will cancel each other, so Kc has no unit. But if the number of mole of reactants is different from the number of mole of product, then Kc will have a unit. So now we will take other example where the number of moles of reactant and number of moles of product are different. So for example, for reaction when the number of moles of reactants and products are not equal, Kc has a unit. Let's consider the following reaction. Nitrogen, when reacts with hydrogen, it gives 2 in H3. Now look over here, 1 mole and 3 mole. So reactants are 4 mole and products are 2 mole. Now Kc will have a unit. So how? First of all, we will write in this form, NH3. This will go to the power and N2, and similarly H2 power 3, because this is the number of mole. So number of mole generally written in power. So now look over here, as we told, the unit of concentration is mole per dm cube or square, and here for this one mole per dm cube, and for this one mole per dm cube, and this is cube. Now look over here, all the units are mole per dm cube, but here the power is 2, here the power is 1, and here the power is 3. So 1 plus 3 equal to 4, and here the power is 2. So this 2 will cancel, 2 ones are 2 and 2 twos are 4. So overall this will cancel, and here we will write power 2. So mole per dm cube power 2. Now multiply this square with this, so it will become mole square, and this will become mole power minus 6. When we send this to the numerator, so it will become mole square will become mole power minus 2, and this minus 6 will become plus 6. So the final unit of this reaction for Kc is mole power minus 2 into dm power 6. So this is the unit of Kc when there are different number of mole on reactant and product sides. So it is a solved example. Equilibrium occurs when nitrogen monoxide gas reacts with oxygen gas to form nitrogen dioxide gas. So this is a balanced chemical equation. At equilibrium at 230 degrees centigrade, the concentration are measured to be, the concentration of NO is this mole per dm cube, and concentration of oxygen is this mole per dm cube, and concentration of nitrogen dioxide is equal to 15.5 mole per dm cube. Calculate the equilibrium constant at this temperature. So first of all, this is given data which we have noted over here. First of all, we will write equilibrium expression. So this is equilibrium expression for this reaction. So this is the product you can see over here, and there are 2 moles, so we write 2 in the power, and this is the reactants 2 NO and O2. Now put these values over here and solve it. So we have put the values, all the values, and we have solved. So Kc is equal to 6.44 into 10 raised to the power 5, and when we calculate this unit, so it will become mole inverse. It means that the remaining over here is mole, and dm cube means the remaining over here for dm cube is power 3. So this is the solution for Kc when the concentration of reactants and products are given. So you can determine the value of Kc like this. This is another example. A reaction takes place between iron and chloride ion S. So iron and chloride ion gives this. At equilibrium, the concentration are measured to be zero point 0.2 mole, and for chloride ion is 0.28 mole per dm cube, and similarly for FeCl4 is 0.95 into 10 raised to the power minus 4 mole per dm cube. Calculate equilibrium constant Kc for given reaction. So look over here. First of all, we will write the given concentration, and then we will write the equilibrium constant for this balanced chemical equation, and then we will put the values, and we will get, after calculating this, Kc is equal to 7.72 into 10 raised to the power minus 2 mole power minus 4 and dm power 12. So if you calculate this, so you will get the final result mole power minus 4 and dm 12. Now, reaction quotient. So what is the reaction quotient? By definition, the reaction quotient is calculated using the concentration or partial pressure of the reactants and products at any point during a reaction, not necessarily at equilibrium, using the same form as the equilibrium constant expression. So for reaction quotient, we use QC, and the remaining terms are written in the same form. Now, what is the difference between a reaction quotient and equilibrium constant? So, equilibrium constant is only work for a balanced chemical reaction and when there is equilibrium, while reaction quotient can be determined at any stage. At any stage of the reaction, you can determine reaction quotient. So this is the main difference. So direction of a chemical reaction. Why we calculate reaction quotient? So reaction quotient is calculated for the purpose to determine the nature of the reaction. For example, if QC is equal to Kc, the reaction is already at equilibrium. So in this condition, if QC is equal to Kc, the reaction will be at equilibrium. And second condition, if QC is greater than Kc, the reaction will proceed in reverse toward reactants to reach equilibrium. So if QC, that is a reaction quotient, is greater than Kc, so it means that it is a reverse reaction. While if QC is less than Kc, the reaction will be forward reaction. And similarly, extent of chemical reaction. So there are also three possibilities. Number one, when Kc is very small, when Kc is very large, and when Kc is neither large nor small. So when Kc is very small, for example, 5.2 into 10 raised to the power minus 13. So it means that reaction is backward reaction. When Kc is very large, so Kc, for example, 2.2 into 10 raised to the power, this is 10 raised to the power 47. This is not 1047, but this is 10 raised to the power 47. So when Kc is very large, because this is very large value, so reaction is forward reaction. And when Kc is neither large nor small, so it means reaction is at equilibrium. So I hope you will have understand all these concepts and definition and numericals regarding chemical equilibrium. If you have any kind of question, so you can ask in comment section. Thank you for watching. Take care. Goodbye.